In 1985, the founder of Commodore and the man behind the C64 left the company and bought Atari. The 520 ST here was designed in just 5 months by a small team led by one of the former Commodore 64 engineers. Today we're going to unbox, restore and explore the initial model of the Atari ST. I picked up this Atari years ago, still in its original box, but I never got around to restoring it. Much later I also found a tiny but matching Atari SM124 display. Okay, let's see what's inside this box. I had a peek inside when I bought this machine, but that was ages ago. And if I remember correctly, the machine was complete, but it had yellowed. The serial number starts with 86, so perhaps manufactured in 1986. Inside the box there is another box, so let's open it up. And inside here we have power supply and yellowed mouse and the RF cable. I can actually see some electrolytic caps through the grill here, and they're not bulging, they look okay, so that's a good start. And the next item is an Atari ST owner's manual. It looks to be in nice condition. It's going through all the basics, how to plug the power cord in, the display and the diskette drive. I'm not going to go through all of this, but it looks like it's a pretty comprehensive manual. So I'll read this later and learn a bit about how this machine works. And the next item is Atari ST Basic Quick Reference Guide for the advanced programmer. Well, I wouldn't consider myself as an advanced programmer, but I did enjoy BASIC on my Commodore 64 back in the 80s. So I'm gonna read through this and compare it to Commodore BASIC. And the next item in here is a tiny instruction manual for the Atari mouse. So if I ever forget how to use a mouse, I'll read it. And the only thing left in here now is a very yellow Atari ST. Well, it may have a yellow keyboard, but aside from that, it looks to be in really good nick. Oh, that is a pretty crappy keyboard. That is not a great keyboard. I think someone has been inside this machine. Let me show you why. When you reinstall the screws after you have been inside the machine, if you over tighten the screws, you will get these white dots. So if we look underneath the machine, we probably have a corresponding screw here. And apparently one over here too. And one on this side. Let's have a look. Yeah, sure enough. Those white dots have corresponding screws here. And this screw is actually missing. And there's a Commodore service sticker here. Why did a Commodore shop service a machine from the competing Atari? Together with this ST, I got the Atari SF314 diskette drive. There wasn't any room for it in the box, so perhaps this was an option, not included when the machine was new. This is presumably the original cable for the diskette drive. That is one really weird connector. I'm not going to count those pins, but they are many for sure. The diskette drive also came with its own power supply. Then we have the display, of course. It didn't come with a machine, but I kept an eye out for one of these and eventually found one on eBay. This could be a bit tricky to do on camera. I'll give it a try. And here's our tiny display. Well, I'm not sure if the SM124 name refers to 12 inches, but it's quite possible. Good news is that the display hasn't yellowed. Well, aside from these knobs here. but it's far from clean. So we're gonna have to take it apart and wash it. Well, we might as well start with the display. And the usual disclaimer, of course. Please don't mess around inside CRT displays. They may be charged with high voltages inside, even with the cord unplugged. That being said, I bought this display ages ago, and I don't think I ever turned it on. So it shouldn't be charged with anything. That also means I don't actually know if it works. So fingers crossed. And it has fixed cords, of course. But I'm not surprised, because these machines were cheap. And actually they were still cheap when I bought it. I don't know if they still are, but this machine was really cheap when I bought it. If I remember correctly, I paid less for this machine here than any Commodore 64 I own. And same thing with the display, I got a similar deal. I don't know if that still holds true, but at least they were cheaper than the Commodore 64. Oh wow, this thing is clean inside. We're in luck. I won the CRT lottery. Yeah, check this out. This display hasn't seen much use. And to be perfectly honest, I'm probably not going to use it all that much either. I will try it out, of course, but I think I'm going to use something better with this machine. Although I did some reading online, and I only read good things about this display. So it's not a bad display. It is a gold star, however, so I'm not sure what to believe. To remove the case, we first have to disconnect the speaker. So let's check for refuzz next. I want to dry clean the tube and wash the rest in soapy water. So let's make a full disassembly, which by the looks of it is going to be a pretty quick and easy thing to do. Just a few screws to remove this bracket here with the knobs. And these guys need some retrobrite too. And I think this whole assembly here will come off with the PCB. It's a bit smelly from storage. Nothing extreme, but it definitely needs a wash. So I'm gonna have to cut the glue to the neck board and remove it. And down here in the middle of the PCB is the connector for the LED on the front panel. So that is gonna have to come off. I think the whole PCB assembly comes off in one piece if we remove two hidden screws inside here. Okay, let's see if my guess was right. Well, it was, but we'll have to cut the zip tie and disconnect the yoke and the ground cable too. And we're in luck. I can't see any smelly refuzz. All caps look fine, and nothing is leaking as far as I can see. This big cap here looks like it's bulging, but it's not. It has this plastic cover on top. Not sure why, but I've seen these before. That cap is fine. I'm just going to disassemble this display, enough to wash it. So I'm going to leave the PCB on the PCB bracket. And just remove these knobs here. And we'll put them back on when they are nice and white again, after some treatment with peroxide. One of the knobs is also the power switch. The only thing left to remove now is the LED on the front panel. And the tube, of course. Perhaps the simplest CRT display I ever had to disassemble. I'll wash all the bits and pieces off camera, so we can move on and disassemble the Atari. Well, this screw looks like a typical Commodore 64 screw, so it should be easy to replace the screw here. This looks like it's a paper label, so I'm gonna have to cover it when I do the retrobrite. I'm kind of guessing here, because I've never been inside one of these. At least not that I can remember. Let's turn it around and see if this cover will come off. No, it's stuck in something here. Oh, there's a screw underneath that service sticker. That's too bad. Unfortunately, I'm gonna have to poke through it and destroy that Commodore logo. It's designed to fall into tiny pieces, so it can't be removed Probably so it should be clearly visible if someone has been messing around with the sticker. Okay, let's try again. Yep, cover is off, and it's quite dusty inside. And I like this yellow color here. This is probably what it should look like. Okay, keyboard is loose, so I'll just disconnect it from the motherboard. Underneath here we have some sort of controller and a logic chip. It obviously needs restoration, so I'll remove all of these tiny little screws. Some of the screws are covered up by this really sticky old tape. Now that's going to be tough to remove, so I'm just going to cut through that sticky tape, just so I can reach all those screws. Yeah, this totally works. That was the last tiny little screw. This pile of screw here kind of reminds me of the Commodore 64. Oh, there's actually one more screw here underneath the cable, and apparently one more screw here. Okay, let's try again. And of course, it's a nasty rubber dome keyboard. And this rubber dome here looks like it hasn't been installed correctly. Oh, it is. So there's an optional pad here. And same thing by the enter key here. So these were probably made as ANSI keyboards or ISO keyboards. Well, since only the display is smelly from storage, I don't think I need to wash every single part of this machine. So I'm just going to leave this PCB. Okay, let's see if we can remove these yellow keycaps. Oh, they're actually double shots. That was a bit of a surprise. So, sorry Atari fanboys. I'm sure this machine is awesome in some other way, but it's not the keyboard. Well, I can't see any brand anywhere on this keyboard, so I don't know who manufactured it. But I'm not going to bore you by removing all these keycaps on camera, so I'll skip ahead here. I decided to stop here and did some thinking, and actually think I'm going to retrobrite these keycaps installed on this board here, because it's much easier. That's how I retrobrite my Commodore 64 keyboards. I remove the spring and then I put all the keycaps back in, and that's a huge time saver, so that's what I do. That means we can move on and remove the shield here. Aside from these screws here, the shield is also held in place with these bent tabs. And apparently Commodore forgot to bend this tab back here, and actually quite a few of them. So let's unbend the few tabs that Commodore actually bent. Okay, let's see if it will come off. It's actually stuck in something more at the back here, so maybe we need to remove the entire motherboard together with the shield. It's not obvious why it's stuck. None of these connectors seems to be stuck, so there must be some hidden tabs here. That kind of sucks. And it's none of the joystick connectors either. Oh, I see, there are actually hidden tabs all the way down here on the PCB. They could be a bit tricky to reach. And I can also see screws down in two of these holes. Let's go for the screws and see if the shield will come off together with the PCB. Okay, 3 more screws removed. Yes, I think this is working. Yeah, the PCB is loose. So let's see if we can get it out together with the shield. That worked. And the motherboard is also shielded at the back. And these tabs are now much easier to reach. Okay, here comes the shield. Okay, let's see what we've got here. Well, that's a nice and neat PCB. And it's actually quite clean. I guess those shields has protected it from dust. It kind of reminds me of a very late Commodore 64 board. The artwork is from week 8 of 1986. And I'm a complete noob to these boards here, but it says CO70243 Rev F. I was expecting to find EEPROMs here. I think I saw that in someone else's video, but perhaps only the very early machines were shipped with EEPROMs. Well, this board is nice and clean, so I'm not going to wash it. There's a tiny amount of dust here, so I'll just wipe that off. We'll have a look at this board later, and we'll see if we can spot what Commodore repaired on this Atari board. Now let's have a look inside a diskette drive. And this drive here has a serial number that starts with 85. And it's actually a very low serial number. So I wonder if this is the matching drive. I hope I didn't mix them up. Although I don't think I have more than one of these. No, I'm pretty sure this drive came with this machine. But who knows, perhaps the original owner bought this drive separately for whatever reason. Okay, let's see how this comes off. Apparently like this. It has two of those weird big ass connectors here. So presumably we can daisy chain two of these. This connector is for power, of course. The drive seems to be held in place with 4 more screws into the case. Okay, now I can lift this off. Well, being a drive from the 80s, we definitely need to have a look inside. Connectors look pretty standard, but the front bezel is definitely not standard. Okay, let's remove that cover and see what we will find. Well, this actually looks pretty good. All of these caps here, they are through-hole caps. And I don't see any leakage. So this may be a really easy project. Let's remove one more screw at the back here. And remove this cover too. No, this looks really good. I think this drive is in really nice condition. Let's test the mechanical parts. Yeah, this is probably a working drive. It's really clean. Looks to be in really good condition. Well, in that case, I'll start cleaning stuff off camera. And I'll see you guys on the other side. Well, the ST was extremely stubborn to retrobrite. I had to do the whole retrobrite process twice. The display cleaned up really well. That case looks pretty much brand new. So let's reassemble it. I wiped the gold star tube with some Windex. And then I washed the case in soapy water. And it now smells nice and fresh. Before I move on and install the PCB, I check for gaps all the way around on the display and make sure it's aligned. In this case it is, since we took the entire assembly out in one piece. The reassembly is also going to be quick and easy. Okay, the PCB knobs are reinstalled. Now let's put that tiny neckboard back on. I'm not going to reapply fresh glue because I don't know what glue to use. And I don't want that stuff to melt when the display is running. Well, since we didn't disconnect much, there isn't much to reconnect either. What a simple design. It took me less than a minute to reassemble the entire display. The speaker is just jammed in here. And then it's locked down with this rod here. The speaker cable is a bit short. It's barely long enough to reconnect. Before we put the lid back on, we need to put these knobs on. They were actually quite stubborn to retrobrite too. And the final step is of course the lid. This Atari, by the way, was manufactured in November of 1989. So it's much newer than the ST and the diskette drive. Before I reinstall any screws in a plastic case, I turn the screw anti-clockwise until I hear a clicky noise. That way I know I'm in the old thread. And I make sure not to over-tighten any screws. The diskette drive is Atari branded, but this is actually a TDK drive. I googled the number at the back here, and apparently this is a double density drive. But some of the early STs actually came with single-sided drives. That is something to watch out for. Although I read in one forum thread that drives with a red LED were single-sided. So someone is wrong on the interwebs. I guess we'll find out if this machine actually works. So if these connectors are standard, you may be able to use a standard diskette drive with an Atari. This PCB here apparently is loose until we have installed screws from underneath. So that's a bit tricky. Let's see if those holes lined up. Yes, they did. So it wasn't too difficult. Oh crap, I didn't notice that the inner front bezel for the drive had yellow too. But I'll fix this later. And the iconic Atari mouse significantly improved in retro brights. All that nasty yellowness is gone. I cleaned all the bits and pieces. So hopefully this is now a fully functional mouse. I have used one of these before. And if I remember correctly, I wasn't very impressed. But who cares about such things? It does look great though. So whoever designed this mouse, I think did a great job. Now let's finish it off. Okay, next up we have the motherboard. Let's turn it around and remove that shield and see what Commodore was up to in this Atari. Well, apparently they replaced this chip here. Let's see what chip that is. You can tell because they probably used solder wick to clean off the solder, and in doing so they also cleared out these vias. All other vias on this board are filled up with solder. I also made a nasty scratch here, and there is some crap left, probably from the Q-tip, but at least they cleaned up the flux. Well, I checked online, and to my surprise I couldn't find a simple board layout like we're so used to with the Commodore 64. And I can't read the text on this chip here without removing this clip. So let's see if we can remove it and take a peek at those numbers. And apparently that is the glue chip. And according to Atari ST internals from 1988, the glue chip literally holds the entire system together, including decoding the address range and working the peripheral ICs. Well, I've got a lot to learn about the system. If you know what the best resource is online for the Atari ST, then let us all know. The keyboard is now 1,000,000 times nicer than it was. I'm not sure if it's perfectly finished. It has sort of a creamy color, but I think it looks quite nice this way, so I'm going to leave it like this. I'm probably supposed to remove all these rubber domes, but since they're stuck to the PCB, I'm just gonna try to install the PCB without moving the rubber domes. Well, that didn't quite work, so this guy here fell off. So unfortunately, I think I have to remove them and install them in the barrel plates. This shouldn't take more than a minute. Okay, all the nasty little rubber domes have now been moved to the barrel plates. So I'm very gently going to install the PCB. There's a tiny LED soldered to the board in this corner. That is giving me some trouble here. So maybe if I position it first. Well, I think that went okay. But we won't know until we have tested the keyboard. So I'll reinstall all those tiny little screws and skip ahead here. By the way, I recognize the sticker here. It looks identical to a sticker commonly found on Commodore 64 keyboards. Could just be a coincidence. Or perhaps the same company that made a Commodore 64 keyboard also made this keyboard here. Well, guess if I made a mistake and installed that rubber dome in the wrong position. So I had to redo the whole damn thing. But that was actually a good thing, because two of the keys here felt kind of weird. Well, worse than they have to be. So I adjusted those two rubber domes and they now feel the same. as the rest of the keycaps. Okay, I think we're ready for a test. So let's connect the display. I'll put a piece of cardboard under the keyboard so we don't short anything, and connect it to the board. And then we need to connect that huge power brick. But I can see through the grill that it's mostly empty space inside. So I guess it has pretty good cooling. So let's turn the display on. And the power knob is also the volume knob. Okay, fingers crossed. Let's see if this machine works. Well, it does something. Yes, it boots. But that image is absolutely tiny. So this display needs some serious adjustments. But hopefully all the pots inside are marked. Oh, the camera doesn't sync to this refresh rate. Let me check. No, there is some weird refresh rate. I can't make my camera sync to this. That kind of sucks. I'll turn the machine off and connect the mouse. Let's see if it works. But I don't know if I have a modern display that will work with this refresh rate. But let's just do a quick test here. So we've got a menu here with desk and desktop info. Oh no, the mouse button doesn't work. Oh crap. That mouse isn't working. I'm gonna have to see if I can find another mouse. Let's try with the space bar. Nope, it just makes beeps. Same thing with the enter key. Oh, that sucks. Can't use this machine without a mouse, so I need to sort this out somehow. Okay, I moved the mouse to the second port. Now, hooked up to that port, the mouse doesn't work at all. Well, I have a mouse somewhere, so I'll go digging for it. But to finish this quick test off, let's try with the joystick. It's actually not working. The cursor just changes shape slightly. Well, maybe this joystick is bad. Let me try with another one. Okay, another joystick connected. Well, it's sort of working, but extremely poorly. And it's moving in the wrong direction. So maybe this joystick is bad too. Or maybe there's something wrong with this machine. I'll find another one. Okay, that joystick didn't work either. So either 3 of my joysticks needs a restoration, or you just can't use a joystick as a mouse on these machines. I did, however, manage to make the mouse work. The switch is just a bit glitchy. So if I push firmly, it actually works. Okay, GEM, Graphics Environment Manager, TOS. Atari Corporation, 1985. Okay, I think that's enough for a quick test. This is pretty neat for 1985. Okay, and in preferences here we can choose between low, medium and high resolution. And this display here is for high resolution black and white. So that's the only option we have. Okay, so that's good enough for a quick test. We'll try out some more in a minute. So let's cover up that board with the shield. Not the easiest shield to install, because I have to line up all those tabs. I'm just going to bend a couple of these, because I plan to do some upgrades on this machine. So I'll just bend enough tabs to keep it in place. And we can drop the assembly into the freshly restored case. This could possibly be the reason why we have those 3 dots on the case. Because there are 2 different lengths of the screws. And maybe these longer screws were installed by mistake. It's actually even worse. There are 3 different types of screws. I'll install the shortest screw in the front row. And then I'll use the mid-size screws at the back here. And now we can connect the keyboard and install it in the machine. And the case looks great after the retro bright. I just realized These keycaps still look yellow on camera, but that is actually my white balance that is a bit off. I have tried to set the white balance manually on this camera, but all my tests have all led to either a greenish color or a yellowish color. So maybe I need a new camera. Anyways, this keyboard is not yellow anymore. It has a really nice creamy white color. I'm gonna install the shortest screw at the front of the case. And I'm making sure not to over tighten. I found a spare Commodore 64 screw. It's identical to the screws on this machine, but it's slightly shorter. Yep, that totally worked. And finally I'm going to use the longest screw at the back here. And I guess that Commodore service sticker is going to remain a mystery. Okay, we're done. Well, we need a mouse to proceed. So I need to fix the switch. The switch is of course sealed, so we can't take it apart and clean it. So the best we can do is to fill it up with deoxit and just hope for the best. Maybe if we're lucky, that deoxit will find its way to the contacts and do its magic. Worst case, I can order a new switch, but that won't help us today. It's completely soaked in deoxit, so I'll be pushing on the switch for half a minute and then we'll try it again. Well, if I push on the switch directly, it responds immediately. Yep, it works perfectly. I'll put the lid back on and we'll test again. Okay, next test. Yeah, totally works. And it actually works perfectly. So another switch saved by deoxit magic. Let's see if we can fix that image next. So I did some reading online, and apparently it's normal to have such a small image on one of these displays. So that was some weird design choice by Atari. But that doesn't mean we can't adjust it. Although some people online claimed that one of the caps can pop if used for long enough with the screen adjusted. But you know me, I pop some caps occasionally on this channel. If that happens, we'll just replace it. And if it's the cap I think it is, I'm pretty sure I even have one in stock. Not that I hope that it will pop, but if it does, we'll fix it. Okay, I think I figured this one out. We need to adjust this coil here in the middle of the PCB. So the bad news is that whoever designed this board didn't want anyone to adjust it, because with the adjustment tool installed, I would have to be poking around quite far inside the display with my bare fingers. So I'm gonna tape something to this tool here and make it slightly longer. And here's what the special tool looks like. It's a standard tool that you can find online. This one is marked PK606A2. This is what I came up with. So I just taped that tool to a regular screwdriver. And this way I don't need to poke around inside the display with my bare hands. The second pot we need to adjust is VR601 here, that I have marked in green. And it's adjusted with a special tool like this. It's basically just a screwdriver, but it's covered by a plastic tube. Okay, here we go. Sorry about that flickering, by the way. In real life here, that image is actually superb. It's extremely sharp and stable, but my stupid camera won't sync to this refresh rate. Okay, let's do some adjustments. I'll start with the coil. Wow, it moves, but extremely slowly. So the image does get wider. I'm gonna stop at least 5 millimeters from the border, because most tubes aren't very sharp out at the edges here. Okay, let's try the other pots. Okay, it seems to be working just fine. And the pot is maxed out at this height. But that is a significant improvement. But the image is still off center. So we have a much thicker border on this side here. To center the image is not as easy as turning a pot or a coil. Instead, we need to cut this glue here. Oh, that was so dried up. It actually just fell off. Okay, so that's fixed. But I need to find that piece that fell down on the PCB. Now we can turn these rings here to adjust the display. It will, however, move in a rather strange way. I'll show you in a few seconds. There are two of these rings. The other one is underneath the yoke here. So if I turn one of the rings, you can see that the image is moving towards one of the corners. And if I turn it in the other direction, it moves down to the other corner. So this is a bit trickier. And you basically have to adjust both rings until you're happy with the result. I'm gonna spend a few minutes here and skip ahead. Okay, I think this is the best we can do. When it comes to the size, it's not perfect, but it's a way larger image than we had before. I'm using a wide-angle lens, so on camera these edges here look rounded, and they actually are, but not as much as on camera. Only this edge here is slightly rounded off, and also the image is slightly tilted like this. To take care of the tilt, we need to undo this screw here. I'm not going to remove it. And then we need to undo the glue here and twist the entire yoke until the image isn't skewed anymore. But before we do, I just want to make sure that the tube is installed correctly. So I'm going to remove these two screws here and check if the screw holes are aligned through these tabs. And they're not. So it's not the yoke that needs adjustments. We need to twist the entire tube. Said and done, I removed these two screws and loosened up the two lower screws. And then I tilted the entire tube until the holes aligned perfectly with the screw holes. And then put all the screws back in. Well, that's interesting. With the tube perfectly aligned, it actually got worse. So we definitely need to adjust that yoke. I loosened up that screw and cut the glue. And wearing gloves, we can now twist the entire yoke to adjust the display. Okay, let's twist that yoke. Yeah, looks about right. I can see on the glue back here that that was less than 1 millimeter. So I'm going to tighten that screw and check again. Because such small movements as when tightening the screw could actually twist it again. Now that looks good. To fix that corner we need to move this magnet here. This yoke actually has a rather unusual contraption. Normally these magnets are just glued in place on plastic tabs. But this guy here actually has adjustment screws. Let's loosen up that screw and see if we can move that magnet. Okay, that should be enough. I am guessing here because I've never seen adjustable magnets like this. It's kind of stuck. So it definitely doesn't move easily. Let's gently pry it and see what happens. Yeah, now it loosened up. So this contraption here was probably a good idea on paper, but it doesn't work too well. I'll remove that screw and see if it helps. Okay, so now this magnet is free to move. I think there's some old glue here, because it's quite difficult to move. I'll put the screw back in, but I'll leave it loose. Okay, let's see how that magnet affects the image. Yeah, just as I thought. So it was like this, but not this much. Yeah, these guys can be quite tricky to adjust. I'm just gonna have to be patient. Okay, that's the best I can do. But this is a huge improvement. I'll show a before and after picture here. Yeah, now I can actually read that text without leaning forward. This display is tiny. Okay, I did some reading, and the cap that tends to blow is a 2.2 microfarad non-polarized electrolytic. On my board here it's an Ichicon part, so I'll be surprised if it blew. But I'll order a film cap rated for a higher voltage, and I'll keep it in my stash in case it ever blows. But I did find something very interesting on the board as I was poking around. Check out C915. What the heck is going on with that cap? I've never seen anything like it. What do you guys think? Should I replace it? I mean, surely it shouldn't look like this, right? What an odd cap. Well, I'm doing my best here to try to read the value of this weird cap, but it's so messed up, it's hard to read. I think it says 272, and then perhaps a 3, or maybe a 0, or maybe a 5. I couldn't really tell. I actually managed to find the schematics for this display online. Apparently that messed up cap is a 2700 pico 630 volt cap. So I now have both caps on the way. I think this is going to be it for the restoration of this Atari. Next up are some upgrades. I want to increase the RAM in this machine and replace that display for something more suitable for gaming. All those suggestions are welcome. If you're watching this sometime in the future, there will be a link to that upgrade video on the screen shortly. If you're watching this fresh, hit the bell icon below and set it to all. I will end by saying thank you to my patrons. I appreciate your support. If you want to support me too, consider becoming a patron. Patrons get ad-free early access. If you like this video, let me know with a thumbs up in the comments. If you're a regular viewer, consider subscribing to this channel. Thank you for watching, I'll see you next week.